Hello, can you hear? We better? Hello? Audio check, mic check. Audio check, mic check. Check, check. Check, check. 1, 2. Check, check. 1, 2. We good? Alright. Oh, okay. Fine. I was like, where the hell is everyone? So I was like, I kept on saying, SJS Smiley, can you hear? Hello, Nerd in Residency, can you hear? I was like, come on, where is everyone? Where is everyone now? So I found out that I had the mic muted because what was it? The last time I showed the video of Scappy, and I showed the video of Scappy, and people were saying, I can hear you drinking. You hear me drinking. And I had to mic the thing. And I was like, oh, okay. Of course, sometimes some settings actually do carry over. I was like, oh, okay. Well, anyway, Thanks for tuning in. Yes, thank you for the mic check, audio check, and thanks for tuning in today. Hello, everyone. I'm Ming Chow. Introduction to Cybersecurity at Tufts University. And today, we're going to talk about password cracking. Password cracking, yeah, password cracking. So, this is how today is going to be organized. We're going to start off with, the wrong way of storing passwords. The wrong ways of storing passwords, how usernames and passwords are stored on modern Linux systems. And then we're going to actually do real demonstration, create a bunch of accounts, a few accounts, and we're going to then do password cracking on them. I think today is going to take the whole time. It's going to take a whole hour and 15 minutes today. So, yeah, all right. So, okay. So what we're going to do now is I brought up Visual Studio Code because I want to do a demonstration on how not to store username and passwords. How not to store username and passwords on a database system. So let's say we have a table. Think of a table. If you're not familiar with what a database table is, just think of a Microsoft Excel spreadsheet, okay, with a whole bunch of rows and columns. And so the columns, I'm going to have a username. That's number 1. And then the password is the other column. So far, so good. So we're going to add a whole bunch of username. This is one nice thing about being on Twitch is I can see username. AYDABEE. All right. Techno247. Oh, this is great. We're going to use username, real usernames here that are Twitch followers. All right, who else can we get? Jasper 2017, okay. You guys all there? Jasper Redang 2014. Okay. I think that's Kevin. Hey, Kevin. So I got 1, 2, 3, 4, 5. I have 1, 2, 3, 4, 5, 6 accounts. Now let's do one more. Bullish token, how are you? Let's use bullish token as well too. I'm gonna use bullish token as well. So here we are. We have a database table of usernames, and soon I'm going to be writing password for each and every user. So the name of this database table is called users. Okay, so I have 1, 2, 3, 4, 5, 6, 7 username. IDABI, Techno257, SJS Smiley, Jasper 2017, Raydang 2014, NGUIE 21, and bullish _ token. Alright, so here is what we are going to do. I'm going to make each and every one of them, I'm going to assign each and every user a password. Actually, I don't want this. That's nice. Alright. here we go. You know how this thing works. So it's going to be username separated by a pipe, and I'm going to have your username is going to be, your password is going to be, actually I just want to space this out nicely. Password is going to be baseball. Techno257, your password is going to be ABC123. SJS Smiley, what do you want your password to be? Plain text. Actually, we're going to do not my password as your password. Jasper, let's pretend that Jasper 2017, your password is Daisies. 321. Rating. Let's say your password is we're just making something up here. Kevin, your password is gonna be Kevin. N 1980 and bullish token, your password, because you have such a great username. Are you ready for this one? It's going to be To the Moon 2022. Yeah, so here it is. Bullish token, your password is, oh, Kim. Hey, sorry, Kim. Hey, Kim. Good Lord. Okay, so bullish token, your username is bullish_token and To the Moon. So this is going to be some fictitious database table of username and passwords. Okay. Now this is going to be I'm just right now making up a fictitious list of username. Well, actually, all the usernames are here, and I'm just making password for each and every one of you 7 people. 2, 3, 4, 5, 6, 7. All right. So now I don't care if you know a thing about databases or not, but tell me in real life what is now a common occurrence. What's now a common incident for databases? Yeah, I just made a number up. I don't know. I don't know. So the question is, what happened to databases these days? You hear about them on the news all the time. Why? Come on. What happened? You hear these in the news all the time. Companies get what? No. In more simple terms. I was really looking for people love to. Okay, there you go. Okay, now we're getting somewhere. So here's the problem. The problem is this: databases are breached all the time. They get hacked. Companies get hacked all the time. Systems get hacked all the time. You get the idea. Yeah, okay, that's a good one. All the important information is in one place. So here's the thing, and I tell everyone this if you're doing cybersecurity, it's not a matter of if you're going to get hacked, it's just a matter of when. It is what it is these days, okay? It's now just a matter of when you will be hacked. Now, just for the sake of argument, imagine that this website or company or institution got hacked, and this was part of the data breach. The list of usernames and passwords, as you see here on the screen. What now if an attacker actually gets a hold of a database and see data like this, as it is, as you see on the screen right now, with username and password, what's the problem? Recall the PCAP lab and lab number 2. Someone already mentioned this. Actually, it was SJS Smiley. You mentioned this already. You just said it. Say it again. Not really, yeah. You can log in. They already did. Someone already logged in as a high-ranking member. Just assume that already happened, Ray Dang. But now, even better is that the attacker, the hacker, actually gets a hold of this entire list as it is, username and password. And as Steve Watha, yeah, there you go. Here you go is they're stored in plain text. Actually, I need to add another person here. Steve. I'm just going to say Steve, and your password is also going to be, I'm going to add an 8th person. ABC123. Your password is also going to be ABC123. So now we have not 7, we got 8 users here. Now, if an attacker gets a list of all these username and password as it is right now, the problem is, as you can see, everything's stored in plain text. It's pretty dumb. So now we know that SJS Smiley, your password we now know in the world is not _my_ password, all in lowercase. So of course this also kind of sucks, because now if you're an attacker, if you're a hacker, you have this list. What are the chances that there is another username, SJS Smiley, and the password is not _my_ password, all lowercase out there? It's going to be pretty high, because people love to reuse username and password all the time. And then, of course, you use this information and you try to hack other websites. This is a password reuse problem. But the big problem, as you both pointed at Steve's and SJS Smiley, okay, now SJS Smiley, where else did I use the same password? People use the same username and password all the time. Why? Psychology. Do you actually want to remember all those username and passwords? Now people have 50, 60, 70 accounts. That's pretty normal these days. How are you going to memorize them all? You can't. So you just use the same password all the time. This is why your best solution is to use a password manager. But going back to this, the problem is, in this example right here, in this list of username and password, the username is in plain text, but also the password is in plain text. That's not good at all. That's not good, because remember, once a system gets breached, there you go. The attacker gets a hold of everything. Here it is. You just left the keys in the car. Passwords are all in plain text. So the big problem is you don't want to ever store passwords in plain text anywhere. Got that? That's the big problem. Now, is there a way that we can do any better? Can we do better than just storing passwords in plain text? And the answer is yes, there is. And this is where we're going to do it a little bit better. We're now, instead of storing the plain text of the password, we're going to store what is called, I'm going to save this, users.txt. I'm going to save this file. The better that now, instead of storing the password, each password as plain text, we're going to store each and every password as a one-way cryptographic hash. So what we're going to do is, instead of storing baseball as it is, ABC123, not _my_ password, Daisy321, need a better GPU, Kevin N 1980, to the moon 2022, ABC123, we're going to store the password now as a cryptographic hash using a one-way hash function. Now, just a review. So if you remember anything from a data structures course in any computer science curriculum, what are the properties, what are the improperties of a one-way hash function for hash tables, for searching? Right, what are they? I need your help here. What's the point? How you do? What are the properties of one-way hash functions? Spread out keys well. Okay, that's one. What's another one? The big one is no collisions, right? So, indexing. Yep, there is definitely an indexing. They can be confirmed without reversing to get the plain text password. Okay, there you go. So a one-way hash function is, how it works is, I'm going to draw it here, okay, hash _function of some input and you're going to get equals some output of fixed size, okay? And the important thing is no two different inputs will share the same output. That's the collision problem. That's horrible, okay? This is only one way. So given an output, you can't reverse and get back the input at all. Length is always the same size. In this case, the output is the same size. Absolutely steez, okay? So one-way hash functions are used for digital signatures. They're used to verify the integrity of software downloads, also known as checksum, and they're also used for passwords as well. Now, there are many, many different types of cryptographic hash functions. Starting off with something like MD5, okay? MD5, you go to MD5 online. Nope, no, let's not use this one. I don't want it. MD5 calculator. MD5calc.com. Okay, this is a good one because this website, actually, you can calculate the cryptographic hash using any of these. These are all hash algorithms. These are all hash functions. MD2, MD4, MD5, SHA-1, SHA-224, SHA-256, SHA-512. These are all different hash functions. These are all different hash functions that you can use, okay? So what's the difference between all of these? Well, what are the difference? Okay, so I'm actually going to use a string to encode. I'm going to use baseball. That's an easy one. So the MD5 hash of baseball is this thing right here, okay? I'm going to give you another string for football. If I actually hit the encode, if I calculate the MD5 hash value of the string football, you're going to get a different value, and the key length is the same, okay? Now, the thing is, MD5 is, how many characters there are? They do an MD5. MD5 stands for Message Digest Algorithms. 128-bit hash value. Okay? So it's a 128-bit hash value. What about SHA-1? SHA-1, encrypted, okay? SHA-1 is a secure hash algorithm. One is cryptographically broken, but still widely used hash function. Okay, and produces a 160-bit, 20-byte hash value, known as a message digest. So this is a 20-byte. Okay, what was MD5? Okay, this was 100. So, of course, SHA-1 is going to be a little bit longer. So let's use, okay, let's go back home. Oh. And I don't want to use MD5. I want to use SHA-1. Let's use SHA-1. Okay? So SHA-1, you can actually hear the last 10 encodings. This is nice. So you can see the MD5, the keys are a lot shorter than SHA-1. We're going to use SHA-1 now to hash each and every password that we have here. All right. So what's the we're going to use SHA-1 of baseball. What's the SHA-1 of baseball? Oh, no space. Okay. The SHA-1 of baseball without a space is A2, yada, 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 362. Spacing matters. What is the SHA-1 hash value of ABC123? That. What is the SHA-1 hash value of S not underscore my underscore password? What is the SHA-1 hash of Daisy's 321? Are you seeing a pattern here? You're going to see a pattern that there is every different input should be a different out. There should be a different output. The key lengths are the same. Need a better GPU. Kevin N, 1980. We're gonna calculate. Great question, Epic Candy. Does a longer hash encoding increase the security kind of crack? You bet it does. You bet it does. Great question. Fantastic question. You bet. To the moon. Okay, and one more. We have ABC 1, 2, 3. Now, again, if I actually calculate the hash, the SHA-1 hash of ABC 1, 2, 3, it should be the one that didn't we calculate that earlier? Yes, we did. You see, you calculate this again on any system, should be the same output. There you go. Sure, oh boy, surety, is there a way to convert that from hash to string? The answer is, well, we'll do that right now. Okay, I want surety, so hold your question for a second. But now, here we are, we have an improved version of a list of username and passwords. Now, what problem did we just solve? We just solved the problem of we just solved the problem of storing password as plain text. Now, here's the good news. The good news is the password is no longer stored in plain text. Now, if you actually just showed up late and you just saw this list as it is, can you make anything of what the password was? You shouldn't. I mean, right now, now I see that the password is just a cryptographic hash value. It's just a cryptographic hash value. There's no longer the password is stored in plain text. But we have two big problems here still. What are they? We have two big problems here of just storing the password as a straight cryptographic hash. In this case, a SHA-1 hash value. No, because there is a word near it, a hacker may try to find out. Okay. Radang says the most important thing. We can see if two users have the same password. Which two users now have the same passwords? Okay, the two people that share the same password in this case are Techno257 and Steez. Now, at Boundus, what you did was you answered Surety's question. The question that Surety asked was, is there a way to convert from hash to string? Ideally, the answer is no. However, Boundus actually wrote something that's important. If there is a common password, can't you just enter that password in the hash and then find it in the list? Here's the thing. The problem out there is, which is really Surety's question, while there is no way to go from this cryptographic hash back to a string, people in the world have already pre-calculated the hash value, whether it's at MD5, SHA-1, SHA-256, of every single dictionary word out there. If you actually use your friend the Google, and you actually do a Google search for a certain cryptographic hash value, you may actually get a result back. In this case, if you actually type in, if you actually do a search for the 6367 cryptographic hash, you will notice, guess what? You will see plenty of websites and services that will actually list, what it was. Where is it? List of latest successful SHA-1. Here you go. So there is no way to there's no function to actually go from a hash to a string. But people in the world have already done this all the time. They have already pre-calculated the cryptographic hash value of every single dictionary word. So this is basically what that bounders actually is what you're trying to say. Someone have already pre-calculated every single 35, 40, I don't know how many dictionary, tens of thousands of dictionary words out there. Now, you may be wondering, why am I using SHA-1 for this example right now? The reason why I am using SHA-1 in this example is because SHA-1 is well known to be cryptographically broken. It was broken by Google a few years ago. There is this nice website called shattered.io that actually explain how was SHA-1 broken. Here it is. We have broken SHA-1 in practice. The industry cryptographic hash function is used for digital signatures and file integrity purposes and protects a wide spectrum of digital assets, including credit card transactions, yada, yada, yada. It is now practically possible to craft two colliding PDF files and obtain a SHA-1 digital signature on the first PDF, which can also be abused as a valid signature for the second file. Okay? So, good doc and bad doc, they both share the same hash value, 3713.42. Okay? And here's the proof. They even provided two different PDF files, totally different, yet they actually have the same SHA-1 digest. Once there is one known collision and a hash algorithm is broken. It's completely broken. Okay? But it takes a long time to do to find a collision. It takes a very, very, very long time. Okay? So ideally, doc 1, doc 2, you should always have a different hash. But when you have two different documentation and they share the same hash value, there's a collision, known collision, the algorithm is cryptographically broken, because it shouldn't be a way where two different documents share the same hash value. Okay? So now, here we have, but I want to go back to this. So this is a lot better. Storing the cryptographic hash value of a password is better than storing the plain text. But you still have some major problems in that someone can just Google and look up a hash value, and then you can probably get the original password from there. That's problem number one. Problem number two is, in this list, a big problem is we have two people that actually share the same password. Techno257 and Steez. So now what do we do? Now, is there a better way to store username and password? How does finding one collision lead to have function being broke? That's it. One collision. Theoretically speaking, a hash function should not have any collisions. Once there is one collision, that's it. Do you use that collision to extrapolate the actual function? There's some math behind it. Yeah, hash a bunch of times. Oh, no, you don't want to hash it all over again. But then, the problem, okay. Ray Dang's thought is not bad. But if you hash it over and over and over and over again, and you do that for each and every person, you know how many, let's say you hash like 3 times. You do it in 3 rounds. But the problem is all we now know is you still have the same problem because we know it's 3 rounds. So you just have to, it's just 3 rounds. Every one is still going to be predictable. In fact, it doesn't solve the problem. If you even hash, let's say we hash 6367 yada 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 3 times. If we actually do a SHA-1 hash of this SHA-1 hash, you're still going to have the same problem as two people. We still know that 2 people share the same password. So we need to have a way where two people have to have a way where, okay, two people, we don't want to know if two people are using the same password or not. We don't want that. So let's go back to the original. Here's the original list that we have. One of the most, and here's an idea. What if we, for each and every word, for each and every password, we append some sort of a random, let's say 2 or 3 letter token. Let's use, in this case for simplicity purposes, let's say two letter token, random token for each and every password. So I'm going to have this token for IWAA, BB, no, SJ Smiley. Your token is going to be CC, DD, EE for Radang. Random token for Kevin is going to be FF. Bullish token, your token I'm going to give you is GG. Good game. And Steve's, you're going to be, well, I'll just give you a crazy one. YZ. Okay? So, this token is important. The point of this token is now what I'm going to do is I'm going to actually, I'm going to make a storage of this hash function, of this token. But the whole point of this token is it's going to be appended to your password. Then I'm going to hash that. So, and then I'll actually store that hash. So I'm going to use IDABI baseball. Baseball, and I'm going to do AA. Because your token is AA. So I'm going to store 7238. ABC123, your BB. Not my password. I'm going to add the token CC to it. Daisy's 321. I'm going to add a DD to the end of this one. DD. Need a better GPU. The token for Radang, your token is an EE. Kevin N. I'm going to add an FF to the end of this. Now remember, the token, in theory, should be random. This token should be random. But it doesn't look random here. Bullish token is a GG. And ABC123, but your token is a YZ. Add a YZ here. And now we store this one. Can different username have the same token? Nah, that usually doesn't happen. Usually it's random. I have never seen the same people have the same token. So now, here we go. All right, so here we go. So now, here is our brand new list of storage. All right, so in this case, this looks a lot better. This looks a lot better. We have the password hash, okay? There's no way that we can tell if anyone here is using the same password, which is good. There's a little bit of a randomness to it. Now, the whole point of this randomness for the password hash is thanks to this random token here, this two-letter token for everyone. There is a proper term for this random small token, like the AA, the BB, the CC, the DD, the EE, the FF, the GG, and the YZ. And the idea is this is called, it's not a token, it's called a password salt. A password salt is used to be appended to the original plaintext password to add some randomness. So when that gets hashed, guess what? The hash value does not look the same. So on modern systems, how it works now is you have the username, the password, and the salt are stored. So if there's a nice little Stack Overflow post that I actually had that I saved, is can someone please help me understand how salting works? So far I understand the following: validate password, generate random string, yada yada yada. Here it is. This is a good answer. Salt is combined with the password before hashing. Now password and salt are clear values and are concatenated, and the resulting string is hashed. This guarantees that even if two people were to have the same password, you would have different results hashing. Also makes attacks known as dictionary attacks using rainbow tables, like the pre-computed hashes of every single dictionary word, much more difficult. Okay? You also probably know that, but it is important to remember the salt must be generated randomly each time. It must be different for each protected hash. I think that answers your question. Blue Cow Dog. Blue Cow Dog is the salt must be randomly generated each time for each and every user. Should be, in other words, it should be different. So, for example, user password is my password, random salt is this thing, the resulting clear text is yada yada yada. How you combine them is up to you, as long as you are using the same combination format every time. In my format, it is your plain text password and then just followed by the salt, no space. Okay? So far, so good? Can you also do the same thing with username? No, well, that's become extremely difficult. Here's the reason why I found this. That is not a good idea. Can you also do the same thing with the username and append the username instead? That becomes too predictable. That becomes way too predictable. That becomes way too predictable. Okay? Random, this got to be a random token, which is salt, as we have here. So using this idea of password hashing with salts, you may be wondering how are usernames and passwords stored and not only stored but also created on Linux-based systems. Okay? So I'm actually going to log into a real Linux-based system to show you. So I'm going to SSH into a place called Workspace. This is my personal workspace I have somewhere in the cloud. Now, if I take a look at all the different user accounts I have, it's only one, mchow01 on this thing. What I'm going to do now is I am going to create 3 brand new users on this system. Okay, Blue Cow Dog, Boundless, and TTomps07. Okay? So far, so good? So I'm going to create 3 brand new users. Here on this system right now, I have only one user, myself. So I'm going to sudo add user boundless. And I'm going to create a password for you. Now, I'm going to make something that is pretty well known. Boundless, take a guess what your password is that I created for you. I'm going to create a brand new user, Blue Cow Dog. Boundless, you think it's password, okay? Blue Cow Dog, what do you think your password is? T-Tomp07, I'm going to do. Okay. And I'll do one more. I'm probably gonna forget the hell. I'll probably forget. I have a short memory here. What do you think Lepidopterine password, your password is? Alright. So now, if I clear the screen, I do an ls/home. Now, you can see I created not one, not two, not three, but 4 brand new users on this system. Blue Cow Dog, Boundless, I can't even pronounce that, T-Tomp07. That is a total of 5 accounts on the system, including myself. So, now I think I kind of forgot what passwords I actually created for Blue Cow Dog, Boundless, Lepidop, and T-Tomp07. So now, I kind of forgot what I entered in. And now, perhaps, Lepidopterine. Okay? Now, perhaps it's time to do password cracking. What are their passwords on this system? I kind of forgot. But let's take a look. Okay? Now let's understand how user accounts and the password hashes are stored on Linux-based systems. Leppy. Let's actually now have an understanding of how usernames and passwords are stored. The most important file is this one. Well, actually, there are 2 important files. You need both of them. Okay? The first file is in what is called the /etc/passwd file. Okay? That's a very important file. On modern Linux system, there is a file called /etc/passwd. And here you go. Boom. Here you go, folks. Hey, there you go. Here's a list of all the usernames and passwords. Hey, Anchor. Here's a list of all the usernames and passwords on the system. There it is. /etc/passwd. Yeah? So what's your problem? You see the password? Leppy, you see a password? Blue Cow Dog, you see a password? Boundless, you see a password here? Hello? No, you don't see a password. Maybe I think, what the where? Back in the ye good old days, we're talking about the 80s and 90s. everything was stored in this one file, /etc/PASSWD. Your username and your password hashes were all stored here. Back in the days. But then the file got abused big time. Okay? Then everything got abused. So what they did was, instead of storing everything into one file called a PASSWD file, I mean, PASSWD stands for password, if you didn't figure that one out yet, but that name has still lived on. So now, instead of storing everything into one file, and instead of having all eggs in one basket, the password hash is in another file. It's in a file called more/etc/shadow. Oof. Permission denied. You need to be root or have root privileges to see this file. more/etc sudo more/etc/shadow. Okay, now you see a little difference. Now enlarge this window. I'm going to do this again. sudo /more/etc/shadow. There you go. Now you see something different? Now you see the username, you see a, what is this thing right here? This looks like gobbledygook. This looks like some password hash here. And you have a whole bunch of numbers. So what's your next question? Come on, I'm looking for a question here. So now we have to deal with not one, but two different files. What are your questions? I'm going to do sudo copy /etc/PASSWD.txt. I'm also going to make a copy of the shadow file. Okay, I'm also going to change owner of each and every text file. Oh, now I have a copy of the password and shadow files. Okay, hold on. We have boundless. Wait, boundless, your question is what hash function do Linux use? Steez is how to decrypt. IDABI, what about the salt? Okay, these are great. SPANG is the salt stored somewhere. Let's take a look at the copy of the shadow file I have. Okay, so these are fantastic questions. This is exactly the question I was looking for. What hash function do Linux use? Boundless, thank you so much. Steez at how to decrypt. Okay, we'll get to that later. IDABI is, yeah, where's the salt? Blue Cowdog said something about base 64. No, base 64 is not used, but SPANG mentioned is the salt stored somewhere. And the answer is, okay, I like that question. Yeah, I think usually if anyone you say base 64, it's probably a joke. Don't worry about it. So let's actually understand. We can actually answer boundless. We need to answer boundless question. What hash function do Linux use? And SPANG is a salt stored anywhere. We need to understand the format of a shadow file and how it is. So I'm going to teach you now how to read a shadow file. Understanding that etc/etc/shadow file. And here's the TLDR. Okay, there are several different authentication schemes that can be used on Linux system. The most commonly used scheme that I perform against the /etc password and /etc/shadow file, which I just showed you. /etc/shadow is a text file that contains information about the system's user's password. It is owned by root, the user root, and the group shadow, and has 640 as permissions. Here's the format. The format is this. How it looks like is this. There you have the username. Then the next part separated by a colon. The next thing is extremely important. It is the encrypted password. So let's take a look at Leppy. $6 $P all the way up to here. all of that is your password hash. So let's understand how to read that. The password is using that $type, $salt, $hash format. $type is the method of cryptographic hash function, hash algorithm, and can have the following values. $1 is MD5. $2A is Bluefish. $5 is SHA-256, and $6 is SHA-512. So where are you? Boundless. Take a look. Boundless. Boundless. What hash function do Linux use? Said it right there. Boundless. Starts with $6. Yep. $6 uses SHA-512. Pretty good. Okay. Now, the salt is everything after the second $sign to the third. So let's take a look at Leppy again. So Leppy, $6, this right here, up to that $, that's your salt. And then after the $sign is the hash. This is your hash. So for Boundless, there's same format. $6, SHA-512. Here's your password salt, random, $. Here's your password hash. So far, so good? Okay. So far, so good. Now, where do you think what we're going to do now? Now we're going to answer, okay, so Idabi, I hope that answers your question. What about the salt? The salt is after the second $sign on the password hash right here. Steez, you're finally looking to decrypt. Okay, if there is only, it doesn't mean no password. Yeah, I think that is what it said. Did it? I think that's what it said. If the password field contains an asterisk or an exclamation point, the user will not be. Oh. Yeah, I think so. The user will not be able to log in the system with using password authentication. I think that was me. Hold on, let's take a look at my stuff. Oh, me, I have a $sign. Oh, I don't have a password. I use a key. Oh, yeah, if there is only a asterisk, as in my case, yeah, there's no password, and I can only authenticate by way of a key. Yeah. A key meaning SSH key. All right. So now, yeah, Postgres also is another mess. Yeah. So for me, I don't have a password on this system. The only way I can log in is by way of a key, an SSH key. I'm going to exit out of this. But I want to go to my desktop, and I want to make a copy, download all of the text files that were there. So I want a copy of the passwd.txt and shadow.txt files. So if I download these files, we have 1, 2, 3, 4 passwords, okay? So now, I know Steve is excited. Let's do some password cracking. Let's crack those 4 users that we had, that we created. And we need to use a password cracker of some sort. Now, there are a couple really famous password crackers out there in the world. But the one I love to start off with is the grand old tool called John the Ripper. John the Ripper is a password cracker. openwall.com/John. John the Ripper is an open source password security auditing and password recovery tool available for many systems. John the Ripper's Jumbo supports hundreds of hashes and different flavor types, yada yada yada. Password cracking can be used for both good and bad. Back in the day, system administrators loved to use password crackers to identify people with weak passwords on their system. Because a weak password is the single point of failure of any system. Okay? Yep, SSH keys, like that. The key is only stored on my system. Private key, a public key is stored in my system, but the public is stored on the server box. So John the Ripper is a free and open source password cracker and been around for decades. Originally designed to crack weak Unix passwords. Okay? Now, the Wikipedia definition of John the Ripper is a free password. Originally developed a Unix operating system. It can run on 15 different platforms. It is among the most frequently used password testing and the most frequently password and combined yada yada yada. Okay. So now I'm actually going to show you how to use John the Ripper. John the Ripper is available for any system these days. But I'm actually going to use John the Ripper on Kali Linux. And then I'm also going to run this on Mac OS as well too. Okay? So now what I want to do, I'm going to log into my Kali Linux box. Can you all see? Clear the screen, man, John. John the Ripper, a tool to find weak passwords of your users. How you run John the Ripper is really straightforward. It's just John and then the name of the file that you want to crack. But before you run John the Ripper, you need to have a way, you need to concatenate both the PASSWD and shadow files. You need to concatenate them into one. So what I want to do is I want to upload the two files I downloaded on my Mac, the PASSWD.txt and the shadow.txt file from my Mac to the Kali Linux. So I'm a 192.168. Dot 140.128 to the workspace directory. Boom. Okay. So I'm going to go to my workspace. I'm going to do more. I'm going to do rm users.txt. Okay. There's screen. So if I do more PASSWD.txt, what we just did. Boundless, blue cow dog, t-tomp, leppy. More shadow.txt. Boundless, blue cow dog, t-tomp, 07, and leppydom. Okay? So now what we need to do is, now I have a copy of the PASSWD file and the shadow.txt file. I just can't run John the Ripper yet. What I need to do is I need to concatenate both the PASSWD and the shadow files. John the Ripper, well, on Kali Linux, have this already provided for you. If you install John the Ripper on Kali Linux, it will also provide a auxiliary tool called Unshadow. Unshadow. The whole purpose of the Unshadow file is to combine the PASSWD and the shadow file into one, so then the result can be sent to John the Ripper. The Unshadow, as you can see from the documentation here, the Unshadow tool combines the password and shadow file so John can use them. You may need this since if you only have these, okay, yada yada yada. So to do this, or to run Unshadow is Unshadow PASSWD.txt and shadow.txt. And there you go, that's the output. So now you have everything all combined into one file. Problem with Unshadow is it only outputs everything to the terminal, but you want to save everything to a file. So what you just do is go Unshadow PASSWD.txt followed by the shadow.txt file, and you want to have the greater than symbol, the output, and you do crackme.txt. Okay? Now, the crackme.txt file, this is what you send to John the Ripper. This is what you send to John the Ripper, and then John the Ripper will try to crack the 1, 2, 3, 4 counts that actually have a password hash. Now, for this class, I have already created a crackme file for you to use. You go to cs116.org. Each and every semester, I run a password cracking competition. Password cracking contest. I have 16 hashes. There are 2 different types of hashes. Don't crack them all at the same time. There are 2 different hashes. One with a $1, that's for MD5, and the other one is $6, which is SHA-512. So there are 2 sets of password hashes here, total of 16. MD5 and SHA-250, SHA-512. Don't crack them all at the same and into one file. You're going to crack them separately. If you crack all the hashes, you get an automatic A for the course, because good luck with that. You don't need to run unshadow or anything. All you need to do is this next step. Now I have a crackme.txt file. I do John crackme.txt. That's all. Load it. Oh shit, they cracked all 3. Just like that. Loaded 4 password hashes with 4 different salts. Boundless, your password was football. T. Thompson, your password was flower. Leppy, your password 1, 2, 3, 4, 5, 6, 7, 8. Boom. Does unshadow match based on username? Yeah, it's like a natural join. Yep, as far as I know, it should be a natural join. Oh, shoot. Who's the only one that we're missing here? My memory's a little short. Oh, crap. Okay, so John the Ripper actually ran through this using its own dictionary, like PASSWD password.lst. Proceed with increment. Now just doing brute force. Blue Cow Dog. Oh, shoot. I forgot what I wrote for Blue Cow Dog. Oh, man. I forgot what your password was. Anyway, let me get out of here for a second. So all you need to do is just run this list using John. And, yeah, you just let your computer run forever. Go out for a cup of tea or coffee or something and come back. You're going to need to run this day and day and day and day. So, okay, I'm going to actually quit out of Firefox, but I'm actually going to be back here. Now, on Mac OS, to install John the Ripper and using Homebrew is brew install Johns-Jumbo. Why is it called John Jumbo? I forget why. It's already installed on a machine. Now here's the strange thing. For some ungodly reason, John Jumbo on macOS does not come with Unshadow. Weird as hell. But I want to actually, now, I'm going to download, oh, here, this is what I needed. I want to make a copy of the crackme.txt that I created in Bye, Dad. Bye, Anchor. Thanks for joining, man. Crackme.txt. I created this on Kali Linux. Clear the screen, more crackme.txt. Boundless, Blue Cow Dog, T-Tomp, Leppy. Nope, we still haven't Blue Cow Dog, we haven't created with yet. Now, I just downloaded crackme.txt from the Kali Linux virtual machine that I had. Now watch what happens when I run John. I should get the similar results. weird. Okay, we got football, we got boundless password. Sorry, you got hacked. Flower, T-Trump, okay. We got ya. Again. Leppy, we got you eventually. Now, just for your interest, using a virtual machine to crack username and password is always going to be a lot slower. So just as a warning for you, if you're going to do password cracking, you want to be using native as best as possible. You want to be using native as much as possible because a native machine will have direct access to things like the graphics cards. Now you actually understand why when you're mining Bitcoin or cracking password. Have anyone ever seen password cracking rigs? Password cracking rigs actually are just like loaded with like GPUs. I mean, they're almost no different from like, you can use a VM, but it's always going to be slower. So if you have like a GeForce GTX or some really nice fancy graphics card, take full advantage of that natively. Okay? So you can use a VM, but you're not going to have peak performance like a native machine or like one of these password cracking rigs. Okay, this sucks. Okay. So blues, we're still messed up on ya. Cali is still running. Okay, you can see the graph is awful here. All right. I'm going to quit out of this. One nice thing is if you quit out of a password cracker, it will actually go, like, it already have a memory of, like, what you were cracking before, yada, yada, yada. I'm going to shut this down. Maybe I get more juice on my actual Mac right now. Okay, we still got blue cow dog. Yep. I'm going to hit Control C out of this. Look, now, the thing is with you, blue cow dog, is I forgot your password. I really did. Now, how they do password cracking in the real life is it's not. If you just run John followed by crack me, it's gonna use one. John the Ripper has a default word list, and if your password is not found on that list, it's going to use it's going to go brute force. But to really speed up password cracking, on any system, you want to be using word lists. Now I want to introduce you to one of the best word lists around, and it's all publicly available on GitHub. I want to introduce you to Daniel Meisler's SecList project. Daniel Meisler's SecList project on GitHub, publicly available, is your security tester's companion. It contains a collection of multiple types of lists used during security assessment collected all in one place. List types include username, password, URL, sensitive data pattern, fuzzing payload, web shells, and many more. The word lists from John the Ripper, I think only have like 30,000 words. That's it. But if you actually go take a look at Daniel Meisler, Daniel Meisler's project, you have a whole bunch of lists here. And here you go, passwords. Here's a list of all, like 500. There's so many password lists here. 500 words passwords. Dark code is one of my favorite. Dutch password list. So many password lists. Exacto, 10 million. Yeah. You have the full 10 million. Hasn't been updated for a couple years. So what I did is I actually have a copy of this project, of this repo. Okay. The whole list. Yep. I use it for assessments all the time. Let's see how many lines, how many words are in dark code. DARKO 0DE. So I'll do word count minus, oh shoot. 1,471,056 words. How about this one? The exacto 10 million. Oh, it's really not really 10 million, but it's really 5,189,454 words. Take a look at that file. More. And there you go. Here is the exacto-net-10-million-password list. Yeah. What about dark code? Okay, that's dark code. How do you use John the Ripper where using a password list? Go back to my desktop. It is John minus word list equals, and then you actually have to specify the path. Is it passwords? Passwords. And we're going to use dark code. Crackme.txt. One remaining password hash. Oh, well, that's it. It just went through all the word lists just like that. Aw. Sorry, we still can't crack blues. I forgot what it was. What about exacto 10 million? Let's use this one. The 1 million variety. One remaining password. Is there a way to have John the Ripper go through more than one word list? Ooh, that's a great question. The answer is you can write a script. Oh, that's weird. That was, is it? Oh, list. Oh, I'm an idiot. I'm an idiot. I actually spelled it all wrong. It's sec list. There you go. Now it's running through dark code. There you go. Thanks, Elwit. The answer to Gradang's question is, it is, as far as I know, I've seen a lot of people, what they did is they just have a script and they just combine every single word list into like one gigantic list. It's going to be like a lot of gigabytes for the word list. I've seen people write scripts of their own before. Now it's going through dark code. I don't know if we're not gonna break Blue's password in time. We're not. But John the Ripper, but really, I'm gonna say, in the interest of time, the best way to crack passwords, use word lists. When LinkedIn was breached in 2012, there was like 60 million accounts on LinkedIn. You know, they were able to recover that crack 60-70% of the password using word lists in a matter of 30 minutes. Okay? One thing I will let everyone know, yes, I did use John the Ripper here because it's well known as a good starting point. A lot of people use now, I mean, people swear by this, especially if you're on Windows system. Now we've gotten to a point where Hashcat has basically been the predominant password cracker. Hashcat is a password recovery tool. It is really, really fast. It is extremely fast, but you're on your own to learn Hashcat. Okay, it can really take advantage of things like GPU. Hashcat, I've heard everyone swears by it now. One last thing I want to show you is the time it takes to crack passwords. Yeah, we're still cracking Blue. Blue, sorry man, we couldn't crack you. I forgot what it was. I think it had Blue in there as a password. BLUE, capital BLUE. Try capital BLUE 321. Hold on. I'm sorry. I'm gonna do a vim dummy list.txt. I'm gonna create my own word list. Blue 321, blue 123, blue 123, blue 123. I'm sorry, man. Now I'm gonna do John minus my word list equals dummy underscore list.txt crackme.txt. The most important thing of this lab is to be patient. I'll just let that damn thing run. Yeah, so one of my favorite posts is also the last final point is this. I'm going to end today with this. Oh, by the way, we don't have class next week. No session next week. The time it takes to crack your password. Here's your number of characters. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 18 characters. If you only have numbers only for your password, it's going to be cracked just like that. Lowercase letters, cracked just like that. Uppercase and lowercase letters can be cracked just like that. But the longer your password is, takes longer. If you have a 15 character password with uppercase and lowercase letters only, it could take 43 million years to crack your password. Okay? If you have a long password that uses uppercase, the worst case is 7 quintillion years. No, we have no class next Thursday, no Twitch next Thursday. The one final point I want to make is any one password can be broken, given enough time. So as 0xcs CSCS Learning said, the most important thing for this lab is to be patient. You're not going to crack all the password, because if you do, you get an automatic A for the course. I swear by that. Usually the winning, for 16, you're looking, full credit is usually between like 6 to 9 password. You crack 6 to 9 passwords, that's like perfect 10 out of 10. But again, it's only going to take a matter of time to crack anyone's password. Yeah, I wouldn't recommend it to run on Kali. If you have Windows, run it on Windows. If you have a Mac, run it on Mac. It only is a matter of time to crack a password. No matter if it's 1 second, 1 minute, 1 hour, 1 day, 1 month, 1 year, 1 eternity, it doesn't matter. It's just a matter of time. The only way that you really, really can defend yourself against someone cracking your password and assume that someone can always crack your password is to use two-factor authentication. That's it. Just a matter of time. I don't know what Blue. We don't know what your password is. Even if your password is really random. Oh yeah, even if your password is really random. A mixture of numbers, uppercase and lowercase letters, symbol. If your password is 18 characters long, it could take 7 quintillion years. Two-factor authentication is that when they send you when you have to take out your phone and you have to enter in a code, even once you enter in your correct password. Your only way. Because imagine if your password is cracked by someone out there, by a miscreant. okay, with no two-factor authentication, with no proof that it's really you that entered the password, then the attacker's in the system. But when you enable two-factor authentication, even if the bad person actually crack your username and password and get into the system, you have to punch in a number. But that number or code is only available to, let's say, a phone that you have in your possession at the given moment. Okay? That's it, folks. We're way over time. And that's password cracking. And the password cracking competition is now up. Happy hacking. Have a wonderful weekend, all.